We have here Fourier sine series example. Our general formula of Fourier sine series is S of x is equivalent to the summation of b sub n sine n pi x over L, wherein the value of this n is equivalent to 1 to infinity. And then this b sub n is our sine coefficient, which is equivalent to 2 over L times the integral of f of x sine n pi x over L dx, okay, with limits from 0 to L. So this is our sine coefficient. So in other words, if we have this general formula, we will solve first our b sub n, the sine coefficient, so that we can find the Fourier sine series of a function. So we have our example. Find the Fourier sine series of f of x is equivalent to x on x is greater than or equal to negative L and is less than or equal to positive L. Okay, so we will solve first our sine coefficient. So b sub n, you write here b sub n. Okay, b sub n is equivalent to 2 over L. I will rewrite this one first. 2 over L, the integral of, we have our function. I will write directly our function as x with limits from 0 to L, and then we have sine of n pi x over L dx. So that is 2 over L x, our function x, and then we have sine of n pi x over L dx. Now if you have noticed here, this integration can be solved using integration by parts. We have here x, and then we have here sine of n pi x over L. So definitely we will be using integration by parts for this particular problem. So in integration by parts, we have to identify what will be our u and then what will be our dv. So for this case, our u is equivalent to x, and then our dv equals this one, sine of n pi x over L dx, so that the derivative of u or du is equivalent to dx. And then this dv, if we integrate this one, we have v is equivalent to the integral of sine. What is the integral of sine n pi x? We have our u n pi x. So the derivative of this one equals n pi over L. And then the integral of sine equals negative cosine. So we will have here the inverse of this n pi over L. We have negative L over n pi, and then cosine, that is the integral of sine equals negative cosine. Cosine of n pi x over L. Okay, so if we integrate this one, again we have that is equivalent to 2 over L, and then the integral using integration by parts, so that is u times v, that is negative xl over n pi, and then cosine of n pi x over L. We have this one, u times b, okay, u which is x times negative L, that is negative xl over n pi cosine of n pi x over L, that is u times b minus v du. So minus times the negative, that becomes positive. So that is equivalent to, we have here u times v minus negative, that becomes positive, L over v du, L over n pi, the integral of cosine of n pi x over L dx, that is v du. Okay, so we will close this one. Okay, this time we will integrate cosine of n. By the way, our limits is from 0 to L. Okay, now if we integrate this one cosine, that becomes sine. Okay, so we have here, if we integrate this one, okay, I will write here, continue, 2 over L, 2 over L, and then we have negative x L over n pi, and then cosine of n pi x over L, we have this one, plus, okay, if we integrate cosine, that is sine, and then reciprocal of L over n pi over L, so it will become L times L, that becomes L squared over n squared pi squared, and then this one is sine of n pi x with limits from n pi x over L with limits from 0 to L. Okay, so have you followed this one? This is L squared over n squared pi squared. This becomes L squared because our u here for integral of cosine, u is n pi x over L, and then the derivative of n pi x over L, we have n pi over L, and then the reciprocal of that we have here L over n pi. So multiplying L over n pi to the reciprocal of this one, we have L squared over n squared pi squared. Okay, so next we will substitute the value of x as L. So this one, so 2 over L, okay, 2 over L, and then upper limits, substituting the value of x to L, that is negative L squared over n pi cosine. So what remains here is n pi, because substituting the value of x to L, cancel L, so cosine of n pi. And then plus we have L squared over n squared pi squared, and then sine of n pi, okay, that is our upper limits minus lower limits, wherein we substitute the value of x to 0. So if we substitute x to 0, this one, so this will become 0, and then this one 0, sine of 0 is equivalent to 0 times this one. Okay, so we have upper limits minus lower limits, so we did not to write the lower limits because all of this one, if we substitute the value of x as 0, will become 0. So we have this one. Okay, now I will rewrite this one again. Rewriting this one, I will write first the positive, so we have 2 for these ones, multiply to this one, cancel L, so 2L over n squared pi squared, and then sine of n pi, if we substitute this one, minus this one, cancel L, that is 2L over n pi cosine of n pi. Okay, you have this one. So I already substitute the value, I already multiply 2L to each equation, each group. Okay. Now, after we have this one, we will now substitute the value of n to determine the value of b sub n. So if our n, this is our b sub n, if we substitute the value of n, because we have here summation of n, summation of your function when n is equal to 1. So when we substitute the value of n as 1, the value of b sub n is. If we substitute the value here, take note of this one, okay? So sine when n is equivalent to 1, so this pi is 180. So sine of 180, actually sine of 180 is equivalent to 0. Okay, so 0 times this one is equivalent to 0. Minus 2L over n pi when n is equal to 1. So 1 times 180 is 180. Cosine of 180 is equivalent to negative 1. Okay, using your calculator, cosine of 180 equals negative 1 times negative, that becomes positive 1 times 2L over n pi is equivalent to 2L over n pi or 1 pi. So we have here 2L over your n is 1, and then you have here 1 pi. Okay, when n is equivalent to 2, okay, if we substitute n equivalent to 2, so what happens here is when n is equivalent to 2, 2 times 180, that is 360. So if we calculate 360, I mean sine of 360, so I will be using calculator. Okay, sine, we have here sine of 360, that is equivalent to 0, so 0. This one is again 0, and then 2 times 180, that is 360, cosine. So cosine of 360, that is equivalent to positive 1. So this one is positive 1 cosine of 2 pi, that is positive 1. So if that is positive 1 times this one equals negative. So this is equivalent to negative 2L over 2 pi. Now, when n equals 2, we have this 1. And then, when n equals 1, 2, 3, okay, when n is equivalent to 1, 2, 3, when n is equal to 3, so sine of 3 pi, 3 times 180, so we have 180 times 3, that is equivalent to 540. Okay, 540. So sine of 540, that is 0. So this will always equivalent to 0 for this case. Okay, this one, so 180 times 3, 180 times 3, 540. 540 cosine of 540, that is negative 1. So negative times negative, that is positive. So this is equivalent to 2L over 3 pi. Okay, when n is equivalent to 4, so again this one is equal to 0, then we go back to the negative, that is negative 2L over 4 pi. When n is equal to 5, we go back to positive, that becomes 2L over 5 pi. When n is equivalent to 6 and so on, okay, we'll write here 6, that is negative 2L over 6 phi. So in other words, when we make our equation for this part, we have so and so on. Notice this one is positive, negative, positive, negative, positive, negative. So if we make this one, we have 2L, okay, 2L times, again this is negative, so we will have negative 1. Negative 1 times 2, that becomes negative 2. And then we have, when n is, notice that when n is equal to 1, you have here positive. When n equals 2, you have here negative. That means n plus 1. Okay, when n is equal to 1, that means 1, negative 1. When n equals 1, so 1 plus 1 equals 2. That becomes positive. Okay, positive. When n equals 2, 2 plus 1 equals 3. That negative 1 raised to 3 equals negative. So we have this one when n equals 2. So this is now the case all over n pi. Okay, so that is our b sub n. Okay, sine coefficient b sub n. Therefore, going back to our Fourier sine series, we have s of x equals this one. So I will write this one again. I will write this one again. That is s of x, okay, which is equivalent to the summation of n will start from 1 to infinity, and then b sub n, we will write b sub n here as 2l negative 1 n plus 1 over n pi. So 2l over n pi, and then negative 1 raised to n plus 1. We have this one equivalent. That is our b sub n. And then we have here sine. Okay, sine of, we have n pi x. Sine of n pi x over L. Okay, so this is now our Fourier sine series of the function f of x is equivalent to x.